everyone. Just a quick refresher. Last time we were looking at our sine function that went around or oscillated around this horizontal diameter. We're going to keep a lot of the things the same in this next problem with one change up. So before we had the ruler at this horizontal diameter, but now in problem 2, we are actually going to change it up and we're going to take this ruler and we are now going to move it to the ground. And we're going to think about this circle, how far it is above the ground. And in my typical classroom, I usually have the trig wheel sitting on top of a desk, and it's typically about 36 inches between the floor and the bottom of the wheel. So for the online video, I'm going to assume the same thing, that there's 36 inches between the floor and the bottom of the circle. All right, so you can see a lot of the things in our question stayed the same. We're going to let the function represent the height of the dot. I've underlined what's different. It's going to be above the ground, measured in inches as a function of t, the number of minutes that has elapsed. We're still going to assume the tire takes 3 minutes to complete a full revolution, and we're always going to start at that 3 o'clock position. So our time in minutes is still going to be the same. So just like before, we're starting at time 0, and then it's going to be 0.75 to go a quarter of the way around the circle, and then 1.5, and then 2.25, and then 3 minutes to complete that full revolution. Okay, and then we're going to keep going around. So at the 12 o'clock position, we're going to be at 3.75. At the 9 o'clock position, we're going to be at 4.5, and then 5.25, and then 6 when we make it back to that 3 o'clock position. All right, so now let's look at the height above the ground. So in that 3 o'clock position, so at our starting moment, we are going to be a total of 46 inches above the ground because we have 36 inches between the floor and the bottom of the wheel. And then remember, our radius is still going to be 10 inches for a total of 46 inches. Okay, and then now we're going to move the dot to the 12 o'clock position. So we are now an additional 10 units above, or 10 inches above, which gives us a total of 56 inches above the ground. At 1.5 minutes, we are back at our 9 o'clock position. And so that means we are 46 units or inches above the ground. At 2.25 minutes, that puts us at the 6 o'clock position, and we are now 36 inches above the ground. And then at the 3-minute mark, we are back at the 3 o'clock position, which means we are 46 inches above the ground. So again, that's the 36 from floor to the bottom of the wheel, plus an additional 10 for the radius of the circle. And then we just keep going around in the circle. So we're back at 56, 46, 36, and 46. All right, so now I want you to take a second and create a graph for this. I want you to plot those points. Make sure you label your inputs and outputs. And then also make sure it has the same concavity as the previous graph. So go ahead and pause the video to do that. All right, so this right here is what your graph should look like. Make sure when you label the output that it's the vertical distance above the ground. In the previous problem, it was the vertical distance above the horizontal diameter. So just make sure that that language on the output is above the ground. All right, and then go ahead and take a second, if you haven't done so yet, pause the video to find the period, midline, and amplitude. All right, so the period is how long it takes to go from peak to peak. So in this case, it is still, it is still going to be that 3 minutes. So 0.75 to 3.75, those are your two peaks for a total of 3 minutes. Our midline is going to be that middle, right? So that's right here. And that midline is going to be 46. So think about it as we're oscillating above and below that 46 inches. And then the last part, the amplitude, oops, let me go ahead and write these in. So period is 3 minutes, midline is 46, and then the amplitude is still going to be 10, because from the 46 to the 56, that's 10 units, and then same thing below, 46 down to the 36, that is 10 units. So that is our amplitude. All right, let's go ahead and move on to the next problem. So we're going to go ahead and change one more thing with our ruler. Okay, so we're going to go ahead and take this ruler again, and it's not going to be at the horizontal diameter, it's not going to be on the floor. We are now going to put it just at the table. And there's about a 2-inch gap between the table and the bottom of the wheel. So we're going to go ahead and use that for our distance between the table and the wheel. So we're going to assume 2 inches. All right, and then everything else is going to stay the same, still 3 minutes to complete a revolution and starting from the 3 o'clock position. So let's go ahead and put in our time of minutes. So 0, 0.75, 1.5, 2.25, 3, 3.75, 4.5, 5.25, and of course 6 for the second full revolution. All right, and then now we are going to take a look at the height above the table. Okay, so for the height above the table at the 0 or the initial starting point, we are going to be 2 inches above that ruler or that horizontal line, and we are going to be 10 inches for the radius. So 2 plus 10 gives us 12 as our starting vertical distance above the table. Okay, let's go to our 12 o'clock position. We still are going to be adding that radius of 10 inches, so that puts us at 22. When we go down to our 9 o'clock position, that brings us back to 12 inches above the table. At the 2.25 mark, that brings us to the 6 o'clock position, and here we're at the bottom of the wheel, so that means we are only 2 inches above the table. Okay, and then when we go back to our 3 o'clock position, we are going up again another 10 inches for our radius, so that means we will be back at 12 inches. And then we just keep going around the circle. So here we're at 22 inches, back to 12, 2, and then we are back to our 3 o'clock position after 6 minutes, so we are 12 inches above the table. Okay, once again, go ahead and plot those points and create our graph, and then find the 3 features, the period, amplitude, and midline. Go ahead and pause the video. All right, so you should find that your period is still going to be 3 minutes. We have not changed that. It's still 3 minutes for a rotation. Our midline has changed. We are now oscillating around that 12-inch line, and our amplitude is still going to be 10. All right, so we've got these 3 graphs right here. So I put them all on one graph. You do not need to do this on your worksheet. But I want you to take a minute and think about what changed and what stayed the same between each of those 3 graphs. So go ahead and pause the video while you think about that. Okay, so things that should stay the same is that we always had the same period. In all 3 of those scenarios, it took 3 minutes to complete one full revolution. And then the other thing that stayed the same is our amplitude. And that's because we were always using the idea that the wheel was 10 inches. So those 2 things stayed the same. And then what changed was the midline. And that was where we placed that ruler or that horizontal line, that the distance from the dot to that line is what changed. All right, and so then the next two questions are kind of diving into the two things that stayed the same. So what would we need to do in order to change the period of the function? And then what would you need to do to change the amplitude? So again, pause the video so that you can take a moment and think about those two questions. All right, so the thing that would change the period would be changing the speed of the wheel. Sometimes I have students that will say that you just need to increase the speed, which is true, but you could also lower the speed, right? You can go around at a slower rotation. So the key thing is that you are changing the speed. And then what would happen to change the amplitude? We would need to change the radius of the wheel. Okay, so what I always like to do when I end the worksheets is to go back to that front page. I leave the front page blank for the summary, so I really want to make sure that we talk about the big ideas from each worksheet so you know what the takeaways are. So on the 7.1 summary, the key ideas would be the sine function, which measures the vertical height above or below a horizontal line. Okay, and then our graph should look like this. So I only showed one full rotation on the screen there so that way you can see what the traditional sine function looks like without continued rotation. All right, the period is the time to complete one full revolution. The midline is a line that represents the middle of the function, or you could also think about it as the midway between the max and the min. And then last, the amplitude. There are two ways to find the amplitude. You can think about it as the height between the midline and the minimum. Or alternatively, you could do the max plus the minimum and divide it by 2. All right, so that is it for worksheet 7.1. See you in the next video.